Okay, good morning class. So today we're looking at trigonometric ratios, probably the last section of it, before we go into the cumulative exercise or the revision exercise dealing with this chapter of work. Okay. So at this point you guys had homework. The homework was exercise 7.12. Okay, any issues here? Yeah, all okay. Alright, so the last part 7.13. Let's see. Restriction on identities. That is your heading for today. Restriction on identities. Alright. Alright. So restriction on identities, we're reading this on page. So on page 250. So at this point we're looking at restriction on identities. When proving identities, we may be required to specify those values of variables for which identity is not valid or invalid. Okay? So, any identity contains a fraction, a function tan of alpha, would not be defined for alpha is equal to 90 plus k times 180. What does that mean? Oh, what is this actually for tan? So on your tan graph, not so. So on your tan graph is basically your asymptotes. Can you see that? So whenever you see tan of theta or alpha or beta, there is an automatic restriction on the equation. Why? Because at the points of 90 or minus 90 or 270 or minus 270 or so on, the identity will be invalid at those points. Okay? Why? Because those are your asymptotes, not so. So again, an identity containing the function tan of alpha would not be defined for alpha is equal to 90 plus k times 180, which is your asymptotes. Your k is an element of integers, since tan of alpha is not defined in any of those values of alpha. An identity is also not defined with any denominators equal to 0. Not so. Remember when we did your algebraic fractions? Not so? With the equations. We always, when we worked out the LCM, we said for which values of x would the identity be undefined, or what we call the restriction on the function, on the graph, or on the equation. Not so. So for the denominators, if it's equal to 0, the sum will be undefined. So if there's a tan, that's in the if there's a trig function or ratio in the denominator, that would be the points at which it will also be undefined. Okay? Or not defined. An identity of the form g of a equals the square root of a g of alpha equals the square root of f of alpha is not valid for those values for alpha for which either f of alpha or g of alpha is negative. So under the root, it has to be positive. So it will be not defined when it is negative. That's basically what they say. So let's look at the first question. Okay, so the first question is from example on page 250. You are told for which values of beta is the identity cos of beta over 1 plus sine beta equals to 1 minus sine beta over cos beta undivided. So is there a tan in that equation? No. So I don't have to say that beta is equal to 90 plus k times 180. If there was a tan, I would have said that first. Does that make sense? Right. So what do we say? For the solution, the denominator, which is 1 plus sine beta, is equal to 0. If that's equal to 0, the sum is undefined. Not so? You all agree with that? So take it over. So sine of beta is equal to negative 1. 0 and minus 1, we take it to the graph. So there's your sine graph. When is sine of beta equal to minus 1? At what point? 270 degrees. So if I represent this, it will simply be beta is equal to 270 degrees plus k times. And your sine graph, it will be k times 360. Right. Or with this denominator, cos of beta is equal to 0. Again, the denominator is equal to 0. So we take this to the cos graph. You guys understand? So where is cos of beta equal to 0? At which values? At which point is this? 90. And this point? 270. Can you see that, people? In other words, if I write it for this part of the graph, it would simply be beta is equal to 90 plus k times. This happens every how many degrees? 360. Not so? Or on the other one, we got beta is equal to 270 plus k times 360, which we already accounted here for. So that's a repeated restriction. So you can write it out twice, or you can see that this solution happens every how much degrees? 180 degrees. So instead of writing this as we have it here, we can write it as so it can just be written as beta is equal to 90 plus k times 360, where k is an element of integers. You guys understand? Huh? Am I moving too fast? No. Okay. Look at example 2. Yes? There. We'll do some financial maths today. So you need to get through these things so you can do some financial maths, okay? Thank you. Alright, let's look at example 2 on page 250. Yeah, 230. Huh? Is the right page? 40. That is right. So, in example 2 we are told for which values of x is the identity 1 minus sine squared x over cos x minus sine x equal to cos x plus sine x. Okay. So, is there a tan there? No. So I don't write x is equal to 90 plus k times 1. If there was a tan, I would have written it. Alright. So what do I say here? In this case, it will be undefined where the denominator is equal to 0. So we cos x minus sine x is equal to 0. So how do I solve for x here? Sorry? With sine over becomes cos x is equal to sine x. Now what? You can say 90 minus, so that can be written as cos x is equal to, so cos x is equal to cos 90 minus x. Not so? So what do I do now? Drop the causes. So I say now my reference x is equal to 90 minus x. Okay, so what question we ask ourselves? In which quadrant is cos? Positive. Not so. Which quadrant is cos positive? 1n. So for quadrant 1, it's going to be x is equal to 90 minus x plus k times 360. You take it over. So 2x is equal to 90 plus k times 360 divided by 2. So x is equal to 45 plus k times 1. And then in quadrant 4, how do you get in quadrant 4? 360 minus 90 minus x plus k times 360. So it's going to give you x 360 minus 90 plus x plus k times 360. So the x is cancelled, not so? So 0 is equal to 270 plus k times 360. What did we k is an element of integers? What did we say here? If a number is equal to a number, no solution. So that is mine. What's his name? But there's an easier way I could have done it. Okay, instead of doing this here, let's put this under here. Okay, there was an easier way I could have done it. The reason why I went down that route is because it was called out first. Okay, we could have said that taking it from here, or from this point actually, we got cos of x equals sine of x. So I could have divided both sides by cos. Not so? Why? Because the angles are the same. So this is tan of x is equal to 1. So you go arctan, so my reference angle here is going to be 45 degrees. So we know that tan has one branch. And tan is positive in the first and the third quadrant. So in quadrant 1, it is just x is equal to 45 plus k times 1. The k is an element of. Okay. So you must be able to pick out where we can use tan. It's going to be easier. Not so. The condition for you dividing both sides to get the tan is when the angles are the same. The angles are the same, then that can be the case. Look at example 3. Example 3 is on page 250. Example 3, they want to know for which values of theta is the identity. 1 over cos theta plus tan theta equal to cos theta over 1 minus sin theta, undefined. So when is it undefined? You see there's a tan there? Immediately I write down what? Theta is equal to 90 plus k times 180. Why? That is for the what? Asymptote. Not so. Now what? What's the next thing we have to look at? Is where cos of theta is equal to 0. 0, 1 and minus 1 I take to the cos graph. Walaikum salam. So where is sine equal to 0? Where is sine 0? At what? 90 or 270. So there I could have written theta is equal to 90 plus k times 180, or theta is equal to 270 plus k times not 180 but 360. Or you could have written this as 1 as theta is equal to 90 plus k times, and this is happening every 180 degrees. But you notice now that this and that is the same. Not so? So if you had picked it out here already, that it's the same, I didn't need to do this. Make sense, people? Okay. If you look here, it is where 1 minus sine theta is equal to 0. So you get over the equal sign, or sine theta over the equal sign, sine theta is equal to 1. We take that to the graph. At 1, for which value of theta would sine theta be equal to 1? At 90. So if I represent this, theta is equal to 90 plus k times 360. But is that not also accounted for in here already? Not so? Yes. So all you needed to do was, let's write that one. It would have been enough for the answer. Okay. You guys understand? So let's choose a sum out of 7.13. I'll do an extra sum for you. Exercise 7.13, and it's on page 251. Okay, which one you want me to do? 5. Okay. So number 5, the sum reads